Good morning, everyone. Today I'm going to give the lecture on the additive or reproductive properties part 2. Now, in this lecture, we have studied the additive or reproductive properties of Poisson distribution. Now, we go for the additive or reproductive properties of Poisson distribution. Let X follows the Poisson distribution with parameter lambda 1 and Y follows Poisson distribution with parameter lambda 2. Be independent, be independent random variables with moment generating functions mx of t is equal to e to the power lambda 1 bracketed e to the power t minus 1 and moment generating function of y of t is equal to e to the power lambda 2 bracketed e to the power t minus 1. Then find the distribution of, then find the distribution, distribution of x plus y. Now we go for the first in Poisson distribution. Here we know that in rough parts, this is the rough parts we have utilized here. Suppose x follows the Poisson distribution with parameter lambda with the probabilities mass function x equal to x is e to the power minus lambda lambda to the power x by x factorial, where x is equal to 0 1 2 dot dot infinity. And now here we find the moment generating function x of t is equal to expectation of e to the power tx, but the Poisson distribution is discrete. That's we take the x equal to 0 to infinity e to the power dx into a small x into p of x. And now after simplify we get the moment generating function x of t is equal to e to the power pi e to the power lambda e to the power lambda into e to the power t minus 1. This is the moment generating function of Poisson distribution. Now in a similar case, we have utilized this. Here is x is the parameter of x is a follows the Poisson distribution with parameters lambda 1. Just here lambda can be replaced by lambda 1. It gives the moment generating function of x. And similarly in a y, lambda can be replaced by lambda 2. We get the moment generating function of y. Now we go for the finding the distribution of x plus y. Here we have we have we have moment generating function x plus y of t is equal to, we have moment generating function mx of t into my of t, since x and y are independent random variables. And we write in the properties of reproductives, and after that we write here e to the power lambda 1 bracketed e to the power t minus 1 into e to the power lambda 2 bracketed e to the power t minus 1 Now base same power must be 8. We write here lambda 1 plus lambda 2 bracketed e to the power t minus 1. This is the moment generating function of x plus y of t. Now this is the moment generating function of x plus y. This is the equation number 1. Since equation 1 can be expressed can be expressed in the form e to the power lambda into e to the power bracketed e to the power t minus 1. Therefore, x plus y is a Poisson distribution with parameter with parameters with parameters with parameters lambda 1 plus lambda 2. Now we can write here x plus y follows the Poisson distribution with parameter lambda 1 plus lambda 2. Hence, this is the result. We can say that the sum of the two independent Poisson variate is follows the Poisson variate with parameter lambda 1 plus lambda 2. Now in general, suppose x1 follows the Poisson distribution with parameter lambda 1, x2 follows the Poisson distribution with parameter lambda 2, x3 follows the Poisson distribution with parameter lambda 3 dot dot xn follows the Poisson distribution with parameter lambda n. Now in a similar results we can follow here x1 plus x2 plus dot dot plus xn follows the Poisson distribution of lambda 1 plus lambda 2 plus dot dot lambda plus dot dot lambda n. And now we can write here summation of xi follows the Poisson distribution of summation lambda I is equal to 1 to n. Here I is equal to 1 to n, which is the moment generating function, of a Poisson variate with parameter lambda 1 plus lambda 2 plus dot dot lambda n. Hence, by the uniqueness theorem of the moment generating functions, we can say that summation of xi is equal to 1 to n is also a Poisson variate with parameter with parameter summation lambda I is equal to 1 to n. Now we go for the some remarks. Some remark. The difference of the difference the difference of two independent Poisson variable independent Poisson variables is not Poisson variable means that we find the what is the distribution of what is the distribution what is the distribution of x minus y. So now here we check that the differences of two independent Poisson variable is Poisson variable or not. That's why we can find the distribution of x minus y, therefore the differences. And now we know that by the reproductive properties mx minus y of t, find the moment generating function of x minus y, we can write here mx plus minus y of t is equal to, we can write here mx of t into m minus y of t. Now here we write mx of t into my of minus t, since by the properties of moment generating function, here is the mcx of t is equal to, we can write the moment generating function x of t, x of ct. In a similar way, here the my, here c is minus 1, that's why here we put it here c is equal to minus 1. And before we have seen that we know that the x follows the Poisson distribution with parameter of lambda 1, and y is follows the Poisson distribution with parameter is lambda 2. Now here we write the moment generating function of x lambda 1 into bracket e to the power t minus 1. Now here we write lambda 2 bracket e to the power minus t, because here minus t is given, e to the minus t minus 1. This is the moment generating function of x minus y of t. Now this is the equation number 2. Since equation number 2 cannot be expressed cannot be expressed in form e to the power lambda into e to the power t minus 1. Hence, we can say that x minus y is not a Poisson variate. Poisson variates. So these are the properties of reproductive properties of Poisson variables. And now we go for the example. We go for the example here. Example. So now we go for the one example here. Just one example is suppose that here the number of calls coming into a telephone exchange between the 9 a.m. to 9 a.m. and 10 a.m. say x1 is a random variable with a Poisson distribution with parameter 3. Now we can write that according to the question x1 follows the Poisson distribution with parameter as 3, and here the next according to the question we write here. And now the next is the similar the number of calls arriving between 10 am to 11 am. X2 follows the Poisson distribution with parameter is 5. And now if x1 and x2 are the independent, and what is the probability that more than 5 calls come in between 9 am and 11 am? Now here we have seen that x1 plus x2, just x1 and x2 are the independents by the reproductive properties of the Poisson distribution. We write x1 plus x2 is follows the p3 plus 5, means that the x1 plus x2 that is follows the Poisson distribution with parameters 8. Now we write here, what is the probability mass function? Probability mass function of this Poisson distribution. Just we write x1 plus x2 is equal to r. We can write here e to the power minus lambda, e to the power minus lambda, and lambda to the power r into factorial r. So what is the values of lambda here? In according to the question, lambda is what? 8. And 8 to the power, we write the e to the power 8 and 8 to the power r by factorial r. This is the probabilities mass function. Now the question is that we find the probabilities of x1 plus x2 is greater than 5. Here we write probabilities of r is greater than 5. Now we write is 1 minus probabilities of r less than equal to 5. Now here we substitute 1 minus less than equal to, means that here is r is going on, r is equal to 0, 1, 2 dot dot infinity. We know that the Poisson distributions in a Poisson distribution. So here we go for the Pr is equal to 0 plus r is equal to 1 plus r is equal to 2 plus r is equal to 3 plus r is equal to 4 plus probability of r is equal to 5. Now after finding these values, 1 minus, after getting these values, it gives the values is 0.19123. Now how will we find r is equal to 0? Substitute r, we take the r is equal to 0, we get the r is equal to 0, here put e to the power 8 and 8 to the power 0 and 0 factorial. And here again r is equal to 1, we substitute here r is equal to 1, then we get e to the power 8 and 8 to the power 1 by factorial 1. Then after that simplify, we get the 1 minus 0.19123, and after simplify we get the result of 0.8088. This is the answer for this question. Now thank you. Thank you. Please like and comments and subscribe. Thank you guys.